Hello, math analysis.
So,
Here are the notes
I'm at
for
that district meeting,
8.3. So the
and
first part of
so-
this is just kind of writing down our identities, our properties. So an even function is a function that is symmetric about the y-axis. For instance, y equals x squared is an even function. And by definition, that means anything that corresponds to negative x is also going to correspond to x. So they have the same value of y as an output. That's an even function. An odd function would be like y equals, say, x cubed. So with a function like this, any value of negative x is going to have the same y value but opposite sign, so negative f of x. So if f of negative x is negative, then f of x will also then be positive. They have opposite signs on the y value. So in terms of your trig, who's even, who's odd? Your cosine function is an even function because if you look at the beginning of your cosine, notice it is symmetric about the y-axis, and so is its reciprocal. So secant would equal this. And the reason why we care is it makes it easier. If you know something's an even function, you can use the symmetry of the graph and only graph, say, the positive side, knowing what the negative side would look like. All your other trig are going to be odd functions. So sine of negative x is going to equal the opposite of sine x, and that's because your sine graph, remember, looks like this. So it kind of rotates about the origin. Its reciprocal is also odd, so this would be minus cosecant x. Tangent is also an odd function, and so is cotangent. Minus cotangent. All right, so, and again, these give us substitutions, like if I was doing a identity and I saw sine of negative x, I could replace it with negative sine x. So that's where we can also utilize those properties. Then you have your co-function properties. Co, actually in this case, means complementary. So I don't know if you remember from geometry, two angles that are complementary both add up to 90 degrees. So your co-function properties, like cosine and sine, it's basically the same graph, but it's a 90-degree horizontal translation of each other. So I'm not going to really say much about these. Again, we will be verifying them using the composite properties that we're about to go through. All right, so your composite properties, these are expanding cosine A plus B, and I'll do my best. You're going to be allowed a note card, but I'll do my best to, if you didn't wanted to have these memorized. Co is also like co-ed, together. So with cosine, the trig stays together. Cosine A times cosine B. But if this is a plus, then you do the opposite sign here, and then it's sine A, sine B. And then if we have the negative, it's still all the cosine, all the trig stays together, but you get the opposite sign. So that was negative, this will be positive. Sine A, sine B. And for sine, the sign stays the same, but the trig gets all mixed up. So that's a plus. So this becomes sine A times cosine B plus cosine A times sine B. And you would do the same for the negative. So this will still be sine A times cosine B minus, so sine keeps the same sign between the terms, and then we have cosine A sine B. So the sine one, the signs get interspersed or mixed, but they keep the same sign. Cosine, they keep the same trig together, but with the opposite sign in between. Now with tangent, it looks like, though it's not true, it starts off as if you distributed the tangent across the parentheses, which is not allowed, but that's how this looks. So it starts off the same way as if you had distributed the tangent to the A and the B. And then in the denominator, it's one opposite sign. So if on top was plus, this will be a minus. Tangent A times tangent B. And for tangent A minus B, again, you start off as if you had distributed, so it looks the same with that same sign, but on the bottom, it's 1. Now it's going to be a plus, because the numerator denominator will have opposite signs. All right, so there are all your lovely composite even cofunction properties. Now, let's start to use them. One of the nice things about using them in your trig, so we see down here, we've got this big long, it's got sine in it, it's got cosine in it, and we know that if you're going to solve a trig equation, you only want one trig type. You don't want both sine and cosine. So this is like my A and my B. You notice A is 5x, B is 3x. I see the sine and the cosine interspersed, and there's a negative here. So that tells me I'm going to be using sine A minus B, where A is 5x, B is 3x. So this simplifies to sine 5x minus 3x equals 1/2. So we have here sine 2x equals 1/2, and we want to solve this. So we are going to take the arcsine of both sides, so that I have here arcsine 1/2, and then we're going to continue up here. So I have 2x equals, so arcsine is the inverse sine of 1/2 plus, looks like we are in radian mode, 2 pi n, because we're going to find our particular from 0 to pi. So I have here 2x is going to equal, remember sine, you'll always have two answers. You can't just plug in plus or minus. So inverse sine of 1/2, it's a positive, so that's opposite, adjacent, rad 3. So it's a 30-degree reference. So this will be pi over 6 plus 2 pi n. And the supplement to that is over here in the second quadrant, so that'll be 5 pi over 6. And if you don't remember how we get that, it's by doing the 180, or in this case pi, minus 5 pi over 6. So you're looking for the corresponding reference angle there. All right, we're almost done with our general solution, but we have to divide everything by 2, and that goes to everybody. Divide by 2, divide by 2. So my general solution is going to be pi over 12 plus pi n, and 5 pi over 12 plus pi n. And that makes it a little bit easy because our particular solution is just from 0 to pi. So my particular solution is just going to be pi over 12 and 5 pi over 12. Because if I add pi to that, I will be outside my range. Okay, so that's one application. Now let's do it with a cosine. So with a cosine, notice here's my A, here's my B, and this is a negative in between. So that tells me I'm going to use the cosine A plus B because it has the opposite sign. So this is cosine theta plus 3 theta equals 1/2. So that tells me cosine 4 theta equals 1/2. And now we're ready to do our arc cosine of both sides, arc cosine of 1/2, and we will continue up here. So 4 theta equals arc cosine of 1/2. That's going to be your inverse cosine of 1/2 plus, and now we are in degrees, woohoo, 360n. So cosine, it's a positive ratio, so we can go to the first quadrant, adjacent, hypotenuse, that makes this rad 3. That means my reference angle is 60. So this will become 4 theta equals plus or minus 60 degrees plus 360n. And now we do have to divide by 4 everywhere. So that tells me my general solution is going to be theta equals plus or minus 15 degrees plus 360 divided by 4 is 90. That's my general solution. We want everything up to 180. So we are going to, you can either do the table. I do tend to like my little table. So the way that works, if n is 0, I would have negative 15 and 15. If n is 1, I'm adding 90. So this would be 75. This would be 105. I'm still within. If n is 2, I'm adding another 90. So this will be 165, which is still less than 180. And what am I adding 90? This would become 195. That takes me out of my range. So those two are out of the range. So my particular solution will be 15 degrees, 75 degrees, 105, and 165. So there's a second application of your composite properties. Now, when doing these problems, give an exact answer using a composite property. The idea here is you're not going to be using a calculator. So you want to choose 2 special triangle values that add or subtract up to 75. So I'm going to use 30 degrees plus 45 degrees. So I know that I'm going to erase this for a second so I can utilize my space. This equals cosine 30 degrees plus 45 degrees. And now what we're going to do is we're going to expand this using your composite property. So that's cosine of 30 times cosine of 45, opposite sign, negative, sine 30 times sine 45. And now you just evaluate. So the cosine of 30 is going to be rad 3 over 2. Cosine of 45 is rad 2 over 2 minus sine of 30 is 1/2, and sine of 45 is also rad 2 over 2. So these always have this look to them, rad 6 minus rad 2 all over a common denominator of 4. All right, so now let's look at sine 105. And again, we want to come up with 2 special values that I can evaluate without a calculator. So I'm going to choose 45 and 60. 45 plus 60 equals 105. And so to expand that is going to be sine 45 cosine 60 plus, use the same sign, then sine, sorry. Nope. Well, I could have done that, but I like to do it in order. Cosine 45 times sine 60. And we evaluate. Sine of 45 is rad 2 over 2. Cosine of 60 is 1/2. We have here a plus cosine of 45 is rad 2 over 2. Sine of 60 is rad 3 over 2. So notice it looks very similar. We have rad 2 plus rad 6 all over 4. They always tend to look like that, and that's fine. Now we have a tangent. Tangent of 345. So with this one, I think I'll rewrite it as tan, probably the easiest is 300 plus 45. And so then expanding, again, it starts off looking like you distributed, though that's not what you really did. Tan 45 all over 1 minus the product, 300 times tan 45. And now we evaluate. All right, so tangent of 300 degrees, that's a reference angle of 60, and tangent is sine over cosine, so that is, and 300 degrees, it's going to be negative, so this is going to be a negative rad 3. 360, yes. Plus, tangent of 45 is just 1. That was friendly. On the bottom, we have 1 minus tangent of 300 is a negative rad 3 times 1. So what you see here, I'm going to rewrite this as 1 minus rad 3 over 1 plus rad 3. With these ones, I am going to ask you to rationalize the denominator because it's a good review of how do you rationalize when you have more than one term. The way you do it is whatever's in the denominator, we're going to multiply by the conjugate. So we're going to multiply top and bottom by 1 minus rad 3. So this will go in parentheses. So the first thing we're going to do, actually I'm going to work it out up here and then we'll come on down, is we FOIL. So 1 minus rad 3 minus rad 3 plus 3. So that's foiling the numerator. The denominator, that's a difference of squares. That's a plus b times a minus b, which remember becomes a squared minus b squared. So 1 squared minus rad 3 squared is that. So now let's simplify this puppy because that's not a final solution. So 1 plus 3 is 4 minus 2 rad 3. That's my numerator. 1 minus 3 is a negative 2. And that negative 2 is like a singleton that goes to each term. I can simplify. So 4 divided by negative 2 is negative 2. And then the other one becomes positive. The negative 2's cancel, and I just have rad 3. That is your final answer for the tangent. So I am going to ask you to rationalize the tangent problem. All right, last thing we have here is just verifying identities. So again, you can work on either side. I'm going to work on the left-hand side for this one, which means you don't touch the right hand. So the first thing I'm going to do is just expand cosine A minus B. So again, that's cosine A times cosine B. The cos stay together, opposite sign. Then we have sine A times sine B. That's the numerator. The denominator, notice this is a singleton. So what I'm going to do is I'm just going to write it under each individual term because I can distribute that singleton to both denominators. They have that common denominator. This is cosine B. And voila, look at the magic that happens. Here, this all just cancels to 1. Here, sine over cosine is tangent A, and the second one is going to give us our tangent B, and we're done. That wasn't too bad, right? So it's basically just being able to apply your composite property. This second one, I'm going to work again on the left side, and so we're just going to use our composite property to expand this. So that's cosine x, cosine 3 pi over 2, which remember is like 270, minus opposite sign, sine x times sine 3 pi over 2, and now we evaluate. So cosine stays cosine, nothing you can do with that. Cosine of 3 pi over 2, well, at 270, remember this is 0, negative 1. So cosine, which is the x value, is 0 minus sine x. Sine of 3 pi over 2 is the y value. So we have negative sine times a negative 1 equals positive sine x, which is what we wanted. So basically, these are just expanding, evaluate, and you should get then your conclusion. Same thing down here. I will work on this side. So it starts off as if you are distributing, which you're not, but that's how it looks, all over 1 minus the product, tan x times tan pi. And then we evaluate. Tangent of pi, so remember this is the coordinate negative 1, 0, and tangent is the y over the x. So tangent of pi is 0, so 1 minus tangent x times 0. This all just simplifies to tangent x, which is what we want. All right, I hope that helped. Sorry I couldn't be there, but I will also take any questions you have tomorrow.